consumer and producer surplus, and wage and price controls. So we know from supply and demand that in a free market, the price of a product is going to move towards the equilibrium price. This is where we have total efficiency. However, sometimes there's outside forces that impact the price, making it artificially high or artificially low, which means that instead of being at the equilibrium price, the price is set above or below that price. When this happens, this is going to impact the consumer and producer surplus. An example of this is rent control. So in a free market, the rent for a town, based on number of bedrooms, would be given at equilibrium, supply and demand, how many places were available and how many were being demanded. However, there's rules about rent control where you can't raise the price of a rent. Therefore, the rent might be artificially low because you can't raise it up to be at equilibrium. Another example would be minimum wage. So again, employment can be modeled by supply and demand. However, if your equilibrium price is too low, then as an employer, you have to pay more because minimum wage assures protections for employees that they will be paid a minimum amount, and that might be higher than the equilibrium price that the market demands. Finally, another example would be cartel pricing. So sometimes large influential groups, which could be really good groups or really bad groups, go ahead and impact the price of certain products on the market. There's a lot of ways to do this. They can withhold products and only release a little bit of a time, or they can use violence and threats to the people selling stuff to make sure that they're making as much money as possible. All of these things and many other factors can affect the price that is set for a particular product. What we want to know mathematically is how having an artificially high or artificially low price will impact our consumer and producer surplus. So let's start by looking at an artificially high price. What this means is that the price is set higher than the equilibrium price. So notice in this graph here that I've picked a price that's higher than the equilibrium price. Remember, the equilibrium price happens where our functions of supply and demand intersect. So our P star is down here. But I've picked a price up above that. And so you can see what happens is when you take that price and you start moving over in terms of quantity, the first function we hit is the demand function. So this price is higher than most people are willing to pay. So we don't even get to sell Q star, our equilibrium quantity. Instead, we're only going to be able to sell a lesser quantity. Now, what that means is that the consumer surplus, or the amount consumers save, is going to go down because the price is already high. So the price that they would have been willing to pay, there's less area up there than we would have had if we were at equilibrium. So the consumer surplus decreases when we have an artificially high price. Now, what about if the price is artificially low? Notice that with an artificially low price, we're picking a price that is less than P star. So you can see here we've picked some price that's less than P star. So when we start moving over towards quantities, we're again not going to make it to Q star. Here, the producer is willing to produce less of this item because the price is not high enough. So we don't quite make it to Q star. And as an impact, when we set the price artificially low, the producer surplus is smaller than it would have been if we made it to equilibrium. So when prices are artificially high, consumer surplus is lower. And when prices are artificially low, producer surplus is lower than what it would have been had we been at equilibrium. So this also impacts the way at which we compute how to find this area. So when we do this, we're still looking at the area between two curves, only now we have to figure out the new quantity that we're going to be selling here. So we'll call this Q minus. And then we have this new price. Now I'm going to call it P minus to match. So I'm calling it something minus because it's low. But when we set up our integral here, we're going to be integrating from 0 to Q minus. Our upper bound is now P minus. And then we're going to be subtracting off whatever this supply function is, S of Q dq. Similarly, if we had an artificially high price, how does that impact our equation? So in our artificially high scenario, let's call this Q plus, because it's artificially high, and we'll call this P plus for our notation. So we're going to integrate from 0 to Q plus. We'll have to figure out our new intersection point, right, between the demand curve and P plus. And now our upper bound is still our demand curve, minus, now my lower bound is P plus. So I'm going to have to figure out how to compute these new intersection points to appropriately set up my integral. So let's look at an example of this. Example 4. Suppose demand is given by P equals 20e to the negative 0.002 Q, and supply is given by P equals 0.02 Q plus 1. Find the consumer and producer surplus. So we're going to start by using the equilibrium point to find what the consumer and producer surplus is before we artificially set a price so that we can compare. So what I want you to notice here is that one of our functions is exponential, so that's our e function, and the other one is linear. The reason why I point this out is because our tactic of setting our two equations equal to each other to solve is not going to work here algebraically. This is not something that can be solved. Therefore, in order to approach this problem, we're going to need to graph both of these functions and then use a calculator or a computer to figure out what the intersection point is. So when we graph these, let's see what it's going to look like. So notice here that when I graph these functions, there's a slight curve in the red line, but the blue line is straight. Remember, our supply curve is always increasing, so that's our supply, and our demand curve is always decreasing. So to find the equilibrium point, we need to figure out where these intersect. I graph these both on my calculator to calculate where they intersect, and it turns out that this happens at P star equals 899 and Q star equals 399.65. I opted to round to 2 decimal places here. You could certainly do this analysis and round to the nearest integer. You're going to need to use any information that the problem gives you about rounding, but if it doesn't, use your best discretion. So I now know my equilibrium points. And now I'm going to use this to compute the consumer and producer surplus. Remember, the consumer surplus is the area between the demand function and our equilibrium price. So we're going to be integrating from 0 to 399.65. So we're going to do our demand function, which we know is 20e to the negative 0.002 Q, minus our equilibrium price, which we said was $8.99 dq. So when we crunch this number in our calculator or doing it out by hand, we're going to get 1,910.71. So I'm keeping consistent with my theme to round to 2 decimal places. Part of the reason why I opted to do that is because our currency system is based on having 2 decimal points, and one of the numbers that we're talking about is currency. Therefore, it makes sense. So price per item has to do with currency. So this is going to be $1,910.71 is our consumer surplus. Our producer surplus, remember, that's the area between our supply function and our equilibrium price. So again, we're going to set up an integral from 0 to 399.65. The top curve now is our equilibrium price, which is $8.99, minus, and now we have to subtract off our supply function. And I want you to notice that our supply function has more than one term. So I'm going to use parentheses because that minus needs to go to both terms. So 0.02q plus 1 dq. So again, you can compute this by hand or you can plug it into some sort of calculator. And when I do this, I get a producer surplus equal to $1,596. So this is actually rounded to 2 decimal places because after the decimal is 0.002. So my consumer surplus is a little bit bigger than my producer surplus. And what I'm really interested in is to see how my artificial prices will impact these different surpluses. So now that we've computed this for our equilibrium price, let's look at what happens if we change the price to be artificially high and artificially low. We now want to see what the consumer and producer surplus will be if we set an artificial price of $4 per unit. So this particular problem doesn't specify whether $4 is artificially high or artificially low. So again, having a picture will really help. Notice here that the equilibrium point is at the same place, which we know is 8.99. But if we didn't know that, it would be pretty easy to determine that a price of 4 is going to be artificially low. So 4 is actually going to be right here because we're counting by 2s. And so when we come over, we're going to keep going until we hit the supply function over here. So remember, supply is increasing, demand is decreasing. So our producer surplus is now going to be this teeny tiny area, which we're expecting to go down. And our consumer surplus is the area above. So some of the things that have changed are going to be the p-value we're using, but also the q star value that we're using, right? We're going to have q plus instead. So we need to figure out where 4 intersects with the supply function. Now, the supply function is linear and 4 is a constant. So we can solve this directly by setting these two things equal. So if we have 4 equals 0.02q plus 1, we can subtract 1 from both sides, then divide both sides by 0.02, and we get q equals 150. So my p minus, because we're low here, is 4, and my q minus is 150. So that means when we're setting up our integrals, we're going to be integrating from 0 to 150. And when we're using our function that we are subtracting in terms of an upper or lower bound, that will be 4. So we're expecting our producer surplus to go down, but we're not really sure what will happen to consumer surplus. Because if you think about the surplus we had before, some of that area may get shifted into the lower portion. So this was our equilibrium point before. So this is what we were giving up, but then we're also gaining this area. So sometimes consumer surplus goes up, sometimes it goes down, sometimes it stays the same. So let's see what happens here. So to compute this area that's shaded in red, we're integrating from 0 to 150 because that's where our new model stops. That's where we hit the supply line, where we're not going to manufacture any more of these. And for consumer surplus, we're going to do the top curve, which is the demand curve. So 20e to the negative 0.002q minus the bottom curve. Well, that's our 4. So now that we have this all set up, again, we can compute this by hand or with a calculator. We're going to get a consumer surplus of $1,991.82. So this is a little bit higher than what we had in the last problem. Last time it was $1,910. So the consumers and the buyers in this scenario actually made out a little bit better because this price was much lower than what they would have been willing to pay. So on average, they gained more from this artificial price. However, the producer surplus is going to be again from 0 to 150. Now the upper curve is 4 minus the bottom curve is the supply function. Because the supply function has more than one term, I'm going to use parentheses. When I compute this, I get $225. So in the last scenario, when we were at equilibrium, the producer surplus was $1,596. When the price is set artificially low, the producers don't get as much out of this deal. So the producer surplus goes down, and the savings on this for them is only $225, which is not as good as it was when we were at equilibrium. Now let's see what happens if we set the price artificially high. Example 4b. So again, we're still looking at our function 20e to the negative 0.002q and a supply function of 0.02q plus 1. But now we're going to set an artificial price of $10 per unit. So again, if we didn't know the equilibrium point, we would need to figure out if this price is high or low, but we do know what it is. It was 8.99. So this is higher than that. We can also see this graphically. So notice we're setting the price right here at 10. So again, we know that our P plus is 10. But we also need to figure out what the quantity is when the price is 10. So we could set 10 equal to our demand function, which is 20e to the negative 0.002q. The reason I can set these equal, but I couldn't set supply and demand equal, is because when we had the supply and demand functions, supply had a q in it. Here I'm just setting it equal to a constant, so the variable only shows up once. So I divide both sides by 20, and I get 1/2 equals e to the negative 0.002q. Then I'm going to take natural logs of both sides and solve for q. When I do that, I get 346.57. So again, I'm rounding to 2 decimal places on all my calculations just to be consistent, but that's the quantity now that I'm going to be using for my integrals. So again, I know that my consumer surplus is going to go down if my price is artificially high because I'm losing area by moving away from the equilibrium point. So I'm expecting this number to be lower than the consumer surplus from the equilibrium, which again was 1910.71. So I'm integrating here from 0 to 346.57. And again, consumer surplus is the area between the demand function and your price. So that's going to give me 20e to the negative 0.002q minus 10 dq. When I plug that all into my calculator to compute that, I'm going to get $1,534.26. So my consumer surplus dropped from the low 1900s into the low 1500s. I was expecting that to go down. Now let's see what happens to the producer surplus when this price is set artificially high. So again, we're integrating from 0 to 346.59, our new Q value. And now with supply, right, we're going to be doing our upper curve, which we know is the 10, minus the supply curve, which again, we're going to use parentheses because there's more than one term. When we crunch this number in our calculator, we get a producer surplus of $1,918.06. So the producer surplus went up. Before it was around the $1,500 range, but now it's in the $1,900 range. So we can see that that was increased from the extra area we gained that the consumers lost. So setting the price artificially high is going to lower consumer surplus and sometimes will raise producer surplus. But this is how we use artificial prices to determine new consumer and producer surpluses.